Hari Om. Hello everyone, I'm Shrees. Welcome back to my channel. Today's video is of class 12 mathematics chapter 6 applications of derivatives. In our last chapter, continuity and differentiability, we have learned that how to find derivatives of various functions, right? So in this chapter we will study how derivatives can be used to find rate of change of quantity, increasing and decreasing function. That is, in that we can determine if the given function is increasing or decreasing, and maximum and minimum. In this, we can find at what point the function is maximum and minimum. Okay, so some more applications are there. See, using derivatives, we can find the equations of tangents and normals, and we can find approximate values. So here, only 3 applications you have to study. That is, first one, rate of change of quantity, increasing and decreasing function, maximum and minimum. So first of all, let's go through rate of change of quantity. See, in the introduction of derivatives, see, I have already mentioned that rate of change of quantity. That is, derivative is the rate of change of quantity with respect to another quantity. Okay, that is, see, for example, we usually write a derivative dy by dx. Right? See, what does it mean? That is, dy. Dy means change in y. Dx, change in x. Okay, that is, when x changes, what is the changes in y? How this y changes when x changes? That is, rate of change of y with respect to x. Another example, ds by dt. Here s is the distance and t is the time. Okay, see, when time changes, what is the changes in distance? Okay, that is the rate of change of distance with respect to time. Okay, that is how this distance changes when this t changes. Okay, so rate of change of quantity refers how a quantity changes with respect to another quantity. Okay, say, let's take one example. If population increases by 1 lakh people for 5 years. Okay, if population increases 1 lakh people for 5 years. So now I say the rate of change of population is 20,000 per year. Okay, rate of change of population is 20,000 per year. Okay, so remember that the rate of change of quantity is calculated by dividing changes of a quantity. Okay, changes of a quantity by another quantity. Okay, that is, rate of change of quantity is calculated by dividing changes of a quantity by another quantity. Okay, so here the rate of change of population, it tells us how this population changes over a period of time. Okay, so you might be understand, right? So here, now let's go through some examples. Okay, you will understand it very quickly. Now look at an example. Find the rate of change of the area of a circle with respect to its radius r when r is equal to 5 cm. See here, what we have to find? See, once again I will read the question. Find the rate of change of the area of a circle with respect to its radius r when r is equal to 5 cm. So here we have to find how this area of a circle changes when radius changes. Okay, and when its particular measurement of radius is given, that when a particular measurement of radius, how this area changes. Okay, that we have to find. That means, see here, what we have to find. See, first of all, you have to decide what we have to find. See, rate of change of area with respect to radius. That means you have to find dA by dr. Right? So first of all, let's write equation of the area of a circle. That is, A is equal to pi r square is the equation of the area of a circle. So here we have to find dA by dr. Not only dA by dr, when r is equal to say 5 cm, what is dA by dr? Okay, that means how this area changes when at a particular measurement of radius. Okay, so let's find dA by dr. Here equation is here, a is equal to pi r square, that is dA by dr. Here a is the area of the circle, r is the radius of the circle. So dA by dr, rate of change of area with respect to r, that is equal to, pi is a constant, pi into derivative of r square with respect to r is nothing but 2r, right? 2r, that is 2 pi r. Okay, so here we have got dA by dr is equal to 2 pi r. We have to find when at a particular measurement of radius, what is the changes in area. Okay, so here that is dA by dr when r is equal to 5 centimeter. How to find? Just substitute r is equal to 5 centimeter. So 2 pi into 5, that is 10 pi. Unit is centimeter square per centimeter. That is area of unit of area centimeter square. With respect to radius, its unit is centimeter. So it is the rate of change of area with respect to radius when r is equal to 5 centimeter. So here we can write rate of change of area with respect to radius is 10 pi centimeter square per centimeter. That's all. Next example, very important question. The radius of a circle is increasing at the rate of 2 centimeter per second. Find the rate at which area of the circle is increasing when radius is 6 centimeter. See, what we have to find? Here we have to find, say it is about circle, right? Okay, so area of the circle. First of all, we will write the equation of the formula, that is area of the circle. So A is equal to pi r square. Okay, now what we have to find? What are given? See, given radius of a circle is increasing at the rate of 2 centimeter per second. That is rate of change of radius with respect to time. Okay, rate of change of radius with respect to time. That is here for a second the radius is changes by 2 centimeter. Okay, that means rate of change of radius with respect to time is given. That is 2 centimeter per second. Okay, now what we have to find? See, find the rate at which area of the circle is increasing when radius is 6 centimeter. Okay, that means for a second how much area, how this area is changing. When the area is radius is 6 centimeter, radius is also changes, so increasing. So when it is 6 centimeter, what is the changes of area with respect to time? Okay, for a second how it changes. Okay, that we have to find. That means rate of change of area with respect to time. That means, see here, find the rate at which the area of the circle is increasing. Okay, for a second how much it is increasing. Okay, what is the changes in area? That we have to find here. That is dA by dt. dA by dt we have to find. Okay, so it is our equation. A is equal to pi r square. See, note that here not dA by dr. Okay, because see it is given the radius is increasing. Okay, radius is increasing per second by 2 centimeter, right? And here we have to find how the area is increasing. Okay, that means area with respect to time. Okay, rate of change of area with respect to time. Okay, now let's find A is equal to pi r square. That is the equation. So from here we can find, see, we will differentiate it with respect to t. Okay, because we need dA by dt and we have dr by dt. Okay, so with respect to t, differentiate it with respect to t, that is dA by dt is equal to, listen carefully, how to differentiate it? Pi is a constant and 2r into dr by dt, right? Because we have to differentiate it with respect to t, not r. If it is r, pi into 2r, right? But it is with respect to t, therefore 2r into derivative of r, that is dr by dt. Okay. Now we have to find dA by dt, right? So 2 pi r, see what is r? When r is equal to 6 centimeter into that, we have to find the rate of change of area with respect to time when radius is 6 centimeter, right? So r is equal to 6 into dr by dt, that is 2. That is equal to 24 pi, right? 2 into 6, 12, 12 into 2, 24 pi centimeter square per second. Okay. For a second, it changes 24 pi. Okay. It increasing. So, here we can say the area of a circle is increasing at the rate of 24 pi centimeter square per second. Okay. That is area of a circle is increasing at the rate of 24 pi centimeter square per second. Now let's go through exercise 6.1. First question. Similar question. Okay, find the rate of change of the area of a circle with respect to its radius r when r is equal to 3 centimeter and when r is equal to 4 centimeter. Here no need of confusion, right? It is given rate of change of area with respect to radius, right? So first of all, let's write the equation of the area of the circle. A is equal to pi r square. A is the area of the circle, r is the radius of the circle. Okay, during exam you should write, okay, A is like A be the area of the circle and r be the radius of the circle. Then equation area of the circle is A is equal to pi r square. Okay, so here we have to find what? We have to find dA by dr, right? That is rate of change of area with respect to its radius, that is dA by dr. dA by dr. Okay, first we will find when r is equal to 3 centimeter. Okay, dA by dr is equal to, here rate of change of area with respect to r, right? So differentiating with respect to r, not t, differentiating with respect to r. So pi into r square, derivative with respect to r is 2r, that is 2 pi r. So when dA by dr, so we have to find rate of change of area with respect to radius when r is equal to 3 centimeter. Okay, that is when r is equal to 3 centimeter is 2 pi into 3, that is 6 pi centimeter square per centimeter. Okay, rate of change of area unit is centimeter square per radius, right? Centimeter. So here rate of change of area with respect to radius when r is equal to 3 centimeter is 6 pi centimeter square per centimeter. Now let's find B. Here also dA by dr, just substitute r is equal to 4 centimeter, right? So dA by dr, we have already find dA by dr. dA by dr at r is equal to, when r is equal to 4 centimeter, that is equal to 2 pi into 4, that is equal to 8 pi centimeter square per centimeter. Okay, so here rate of change of area with respect to its radius when r is equal to 4 centimeter is 8 pi centimeter square per centimeter. Second question, the volume of a cube is increasing at the rate of 8 centimeter square per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? It's about cube. Okay. So here what is given? Volume of a cube is increasing at the rate of 8 centimeter square per second. That means the volume is increasing at the rate of 8 centimeter square per second. That is, for a second the volume is changes by 8 centimeter square. Okay. Here we have to find surface area, right? Surface area of the surface area increasing. It is 8 not centimeter square cube, right? volume is cube. Okay. So surface area, we have to find how fast is the surface area increasing when the length of an edge is 12 centimeter. So here we have to find rate of change of surface area with respect to time, because how fast, okay, for a second, what is the changes in surface area when the edge, that is length of a cube, is 12 centimeter. Okay, here length is also changing. So when the length is 12 centimeter, what is the rate of change of surface area with respect to time? See how fast the surface area increasing. That means rate of change of surface area with respect to time. Okay, how fast means with respect to time. So here, first of all, let x be the length of the edge, okay, of a cube. Then next, what is the volume of a cube formula? V be the volume, so volume V is equal to x cube, right? And surface area S is equal to 6x square. Okay, that is the formula. Okay, volume of a cube is, if x is the length of the cube, means side length of the side, then volume is x cube and surface area is 6x square. Okay, so here what we have to find? What is given? What are given? Here volume of a cube is increasing at the rate of 8 centimeter cube per second. That is dV by dt is given, right? Centimeter cube per second. Okay, that is the volume is increasing at the rate of 8 centimeter cube per second. For a second, its change is 8 centimeter cube. Okay, so dV by dt is given, that is 8 centimeter cube per second. Okay, what we have to find? ds by dt, rate of change of surface area with respect to time. ds by dt we have to find. We have a formula, s is equal to 6x square. So from this we will find, okay, first of all let's differentiate it because it is given, right? Differentiate it with respect to t, that is dv by dt is equal to 3x square dx by dt. Okay, here dx by dt is not given, so don't be confused. dv by dt, don't worry, here let's find. Okay, dv by dt is equal to 3x square, because here we differentiating with respect to t. Okay, because we need to find, see, it is given dv by dt and we have to find ds by dt, therefore we differentiating with respect to t. Okay, that is dv by dt is equal to 3x square into derivative of x with respect to t, that is dx by dt. Okay, now next we will differentiate it. Okay, that is ds by dt is equal to 6 into 2x dx by dt. Okay, now here see what is dv by dt? dv by dt is 8. 8 is equal to 3x square dx by dt. Now we need this dx by dt, right? So what is dx by dt? dx by dt is equal to 8 divided by 3x square. Let's substitute this 8 by 3x square here. Okay, that is 6 into 2, 12, 12 into x into 8 divided by 3x square. 1 x cancelled, then 3 ones are 3 fours are. Okay, that is here 32 divided by x, right? Now let's substitute x. What is x? That is length of the edge. It is given when the edge is 12 centimeter. What is the rate of change of surface area? Okay, how the surface area is increasing at the rate of, see, when edge is 12 centimeter, that is 32 divided by 12, that is equal to 2 6 are 2, 16, 2 3, 2 8. So 8 by 3, that is 8 by 3 centimeter square per second. Okay. So here the surface area is increasing at the rate of 8 by 3 centimeter square per second. Okay, it is the answer. That is surface area, that is rate of change of surface area. Okay, per second the changes of surface area when the edge length is 12 centimeter is 8 by 3 centimeter square per second. So here you can write the surface area is increasing at the rate of 8 by 3 centimeter square per second. Next question. The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeter. Very simple question, right? So here what is given? The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Okay. For a second, the rate of change of radius is 3 centimeter. Okay. That is, the radius is increasing by 3 centimeter. That means radius of a circle is increasing at the rate of 3 centimeter per second. That is, dr by dt is given, that is 3 centimeter per second. Okay. First of all, let's write the equation of the area of the circle. Area A is equal to pi r square. Okay. We have to find the rate at which the area of the circle is increasing. That means how this area is increasing when the radius is 10 centimeter. Okay, when the radius is 10 centimeter, what is the changes in area? Okay, how this area is increasing? So that means for a second, how this area is increasing? That means radius, that is rate of change of area with respect to time. Okay, how it increasing means with respect to time. That is rate of change of area with respect to time. Okay, so here it is given rate of change of radius with respect to time is 3 centimeter per second. Our equation that is area of a circle is A is equal to pi r square. A is the area of the circle, r is the radius of the circle. So here let's differentiate it with respect to t. Okay, because it is given dr by dt and we have to find dA by dt. Okay, so dA by dt differentiating with respect to t, dA by dt is equal to pi into 2r into derivative of r with respect to t, that is dr by dt. Okay, direct substitute. Okay, 2 pi into, when r is equal to, when the radius is 10 centimeter, so r is equal to 10 into rate of change of radius with respect to time is 3, that is equal to 10, 20, 60, right? 60 pi centimeter square per second. Okay, per second. So here we say the area is increasing at the rate of 60 pi centimeter square per second. It is the answer. The edge of variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume of the cube increasing when the edge is 10 centimeter long? So here what is given? The edge of a variable cube. Variable cube is, it's not constant, it varies. Okay. So the edge of a variable cube is increasing at the rate of 3 centimeter per second. Okay, so here the side of cube, okay, side of cube is increasing at the rate of 3 centimeter per second. So what we have to find? How fast is the volume of the cube? That means rate of change of volume with respect to time. How fast with respect to time? How fast is the volume of the cube increasing when the edge is 10 centimeter long? That is, when the side is 10 centimeter long, so what is the change in volume of the cube? Okay, that is, see, first of all, let x be the length of the edge. length of the edge. Okay. And here, what is the formula? Volume of the cube. If x is the length of the edge, then v is equal to x cube. Okay, x is the side of the cube, then v is equal to x cube is the volume of the cube. So what is given? So next we will write what is given. The edge of a variable cube is increasing. Edge means side, right? Side of a cube is increasing at the rate of 3 centimeter per second. Okay. So that is rate of change of side with respect to time is, so dx by dt. Rate of change of side with respect to time. That is equal to 3 centimeter per second. We have to find how fast is the volume of the cube is increasing when the edge is 10 centimeter long. Okay. So rate of change of volume with respect to time, that is dv by dt is equal to, that we have to find. Okay. We have to find dv by dt. So v is equal to x cube. So here also we will differentiate it with respect to t. Okay. Because we need to find dv by dt. So dv by dt is equal to, differentiate it, 3x square into derivative of x with respect to t, that is dx by dt. Okay. That is equal to 3x square. See, what is x square? X is given, right? That is when the edge is 10 centimeter long. Okay. When the side is 10 centimeter, what is the changes in volume? Okay. So here 3 into 10, 10 square, right? 10 square into dx by dt is given 3. That is 3 into 3, 9, 900, right? 10 square is 100. 900 centimeter, in centimeter, right? Centimeter cube per second. Okay. So here volume of a cube, volume of cube is increasing at the rate of 900 centimeter cube per second. Okay. That is rate of change of volume with respect to time when the length is 10 centimeter long is 900 centimeter cube per second. A stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? See, here we noticed that when we drop a stone into a quiet lake, some circles formed, right? And waves move in the circle. Okay. Here it is given waves move in circles at the speed of 5 centimeter per second. That means, see, we know that initially the waves move from the center, right? So it moves the speed of 5 centimeter per second. That is the radius. Okay, radius is increasing at the rate of 5 centimeter per second. Okay, so for a second the change of radius is 5 centimeter. That is what is given? dr by dt is given. Okay, now what we have to find? It is, we have to find how fast is the enclosed area increasing. See how the area changes for a second. Okay, that we have to find. When the radius of the circular wave is 8 centimeter. Okay, when the radius is 8 centimeter, okay, 8 centimeter, what is the changes in area for a second? Okay, so that we have to find. So first of all, let's write equation. A is equal to pi r square because it is a circle. Okay, so A is equal to pi r square. A is the area of the circle, r is the radius of the circle. Now what is given? dr by dt, that is radius is increasing at the rate of 5 centimeter per second. Radius is increasing here, right? Okay, so dr by dt, that is equal to 5 centimeter per second. What we have to find? dA by dt, rate of change of area with respect to time. How fast is the area increasing, right? That means dA by dt, the rate of change of area with respect to time. Okay, So let's differentiate it with respect to t. Okay. A is equal to pi r square. Differentiate it with respect to t. dA by dt is equal to pi into 2r into derivative of r with respect to t, that is dr by dt. Okay. That is equal to 2 pi. What is r? See here we are asked to find the rate of change of area with respect to time when the radius of the circular wave is 8 centimeter. Okay, that is how this area is increasing when the radius is 8 centimeter. Okay, so r is equal to 8 into dr by dt is given, that is 5. Okay, so 10 into 8, that is 80 pi centimeter square per second. So here the area is increasing at the rate of 80 pi centimeter square per second. Area is increasing at the rate of 80 pi centimeter square per second. The radius of a circle is increasing at the rate of 0.7 centimeter per second. What is the rate of increase of its circumference? Very simple question. It's about the circumference of a circle, right? Okay. So what is given? What we have to find? We have to find rate of increase of its circumference. So let's write circumference of the circle formula. C is equal to circumference of the circle. C is equal to 2 pi r, right? So what is given? Radius of a circle is increasing at the rate of 0.7 centimeter per second. That is rate of change of radius with respect to time. That is dr by dt is equal to 0.7 centimeter per second. What we have to find? Rate of change of circumference with respect to time. Okay. How the circumference changes. So that is here C is equal to 2 pi r. So dc by dt, because we need to find rate of change of circumference with respect to time, right? So dc by dt, that is equal to 2 pi is constant, 2 pi into derivative of r with respect to t, dr by dt. That is equal to 2 pi into dr by dt is 0.7 centimeter per second. Okay. That is equal to 1.4 say pi, 1.4 pi, it is circumference, right? So centimeter itself, centimeter per second. Okay. So here the circumference is increasing at the rate of 1.4 pi centimeter per second. Okay. Circumference is increasing at the rate of 1.4 pi centimeter per second. Look at the next question. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute and width y is increasing at the rate of 4 centimeter per minute. When x is equal to 8 centimeter and y is equal to 6 centimeter, find the rates of change of the perimeter and the rate of change of area of the rectangle. It's about rectangle. So here x is the length and y is the width of the rectangle. So here it is given the rate of change of length. Okay, see the length is decreasing for a minute. Okay, for a minute the length is decreasing. Okay, that is length is decreasing at the rate of 5 centimeter per minute. Okay, so here, okay, first of all we have to find the perimeter, right? Rate of change of the perimeter. So what is the perimeter of a rectangle when x is the length and y is the breadth? Sorry, y is the width. Okay. So here perimeter P is equal to perimeter P is equal to 2x plus 2y. Right? 2x plus 2y. So next, what we have to find? See, what are given? What are given? The length x of a rectangle is decreasing at the rate of 5 centimeter per minute. That is rate of change of length with respect to time. That is given. That is dx by dt. Okay. That is dx by dt is given. That is, see here, you should be careful here. It is decreasing. Okay. It is decreasing at the rate of 5 centimeter per minute. That means decreasing means dx by dt is minus 5 centimeter per minute. Okay. It is decreasing. Therefore, dx by dt is equal to minus 5 centimeter per minute. Next here, and the width y is increasing at the rate of 4 centimeter per minute. So, when it is increasing, the dy by dt is equal to 4 centimeter per minute. Okay. Dx by dt and dy by dt are given. We need to find the rate of change of perimeter. That is for a minute. See, it is given the length and width is, rate of change of length and width is in per minute, right? For a minute. So our perimeter will be rate of change of perimeter with respect to time, that is also will be in minute. Okay. So here we have to find rate of change of perimeter with respect to time. Okay. How the perimeter changes for a minute. Okay. See here, it is our formula. P is equal to, perimeter P is equal to 2x plus 2y. X is the length of the rectangle, y is the width of the rectangle. So here dp, let's differentiate it with respect to t. dp by dt is equal to 2 into dx by dt plus 2 into dy by dt. Okay. That is, substitute 2 into dx by dt is minus 5 plus 2 into 4, that is equal to minus 10 plus 8, that is minus 2 centimeter. Perimeter, right? Perimeter, centimeter itself, not centimeter square, centimeter per minute. See, what does it mean? Here, the perimeter of this rectangle decreases at the rate of 2 centimeter per minute. Okay, that is, we have got dp by dt, rate of change of perimeter with respect to time, is minus 2 centimeter per minute. That means here the perimeter is decreasing. Okay, since it is minus, we should write the perimeter is decreasing at the rate of 2 centimeter per minute. Okay, perimeter is decreasing at the rate of 2 centimeter per minute, not second, minute, because our length and breadth are the rate of change of length with respect to time, that is in minute. So here perimeter should be in minute. Okay. Next we have to find rate of change of area of the rectangle with respect to time. How the area changes for a minute. Okay. So here when this x is equal to 8 centimeter and y is equal to 6 centimeter. When the length is 8 centimeter, when a particular measurement of length and breadth, then what is the rate of change? That is, what is the change? How this area changes with respect to time. Okay. So here when x is equal to 8 centimeter, y is equal to 6 centimeter, what is the rate of change of area with respect to time? So first of all, here we have to write formula, right? That is, area of the rectangle is A is equal to x into y, right? So differentiate, we have to find dA by dt, right? dA by dt is equal to x into dy by dt plus applying product rule. Okay, derivative first function into derivative of second function plus second function into derivative of first function, y into dx by dt. Okay, substitute x is equal to 8 into dy by dt is 4 plus y is 6 into dx by dt is minus 5. Okay, that is equal to 32 minus 30, that is equal to 2 centimeter per minute. Okay, see here we have got 8 4s are 32, yes. Okay, 32 minus 30, that is 2 centimeter per minute. So we have got rate of change of area with respect to time is 2 centimeter per minute. That means the area is increasing. Okay, here since it is plus, area is increasing at the rate of 2 centimeter per minute. Okay, so here we write area is increasing at the rate of 2 centimeter per minute. Okay, for a minute the change of area is 2 centimeter. Okay,